Hi folks, so the question we have in front of us here today, guys, is a question from the topic of solids in contact. It comes from the book Graphics in Design and Communication, page 51. And we can see here the problem says the diagram in figure 3.43 shows the elevation and two spheres of a cone in contact, okay, with one another. Draw the elevation and plan of the solids showing all points of contact. Okay, so first of all, we'll just have a quick look at the question. So as it says, we can see here we've obviously got the elevation here, okay, of a cone and two spheres in contact with one another and the cone, okay. So we can see the cone has an overall height of 100 millimeters, 40, 75, yeah, 100 millimeters, and it has a radius when we looked on top of it, so it's obviously diameter is 90, radius 45. Okay, so being able to draw the cone in elevation and plan is quite easy. And then we've obviously got two spheres, okay, so focusing on the first sphere here, the blue one, we can see that it is sitting on the horizontal plane, the XY line, and it is 25 millimeters up from the XY line. Therefore, right in the middle, we can draw that straight away in our elevation view, okay, because it has a radius of 25. And then from here, from the center of this sphere, the blue one, up to the center of the yellow one, it's a distance of 40 millimeters. However, it does not tell us the radius for the yellow sphere, okay, so we're going to have to work out that in a while, probably using Loci or something like that, okay. So basically what we have to do is we have to draw the elevation of that in elevation and plan views of this structure here, okay, locating all points of contact. Okay, so we're going to get that started there now, guys, alright. So I got started off the question, guys, and as you can see, I've drawn in my cone, okay, and I've drawn in my sphere A in my elevation view. And obviously we know sphere A in plan is going to be somewhere down here. But we have to get the exact, we don't know where the exact center of it is down along here, okay? Because the center of sphere A, obviously as we see there in our elevation, is up here. And as I project it down, I don't know exactly where it is at this moment in time. So what we do with sphere A is we want to get it on the extreme generator of the cone, okay, first of all. So that's what we'll do there. Just getting that started. So project over the center, because the center line has to be at that height. And what I can do then is I can bisect the angle that the extreme generator makes with the horizontal plane. So this angle here with the XY line. So I'm going to bisect that angle there. So, having bisected that angle, I can now find the center of what would be a ghost sphere. Okay, and we can see I've located the center there. So what I'll do now is I will project that center down. Okay, when it's on the extreme generator, it's going to be here, and in this position then I will rotate it around. Okay, check this, rotate it around. Happy with that there. I have now found the center position for sphere A in my plan view, so I'll draw that in now. Okay, nothing here is heavy at the moment. I'm using a red pen for my construction lines because I know I have another sphere that I'm going to call sphere B, okay, that has to go in as well. So in my plan view, I've drawn in, just fits on my page, okay, put that down there, you can see it just fits. Trying to keep it all within shot there. Okay, so sphere A is done in my plan view now. Okay, so that's half the battle. While I'm at it, I will put in my, just to find it here now. Okay, I'm going to put in my sphere A as a ghost sphere when it was on the outside. Okay, and I'll write that in there as well. So that's the sphere when it was rotated to the outside of it on the extreme generator. Okay, because I think I'm going to need that when I am getting, so it's right in there, ghost sphere. And the reason that helped us is because it helped us locate the center when it was on the extreme generator and we rotated into position then. Okay, and as I said, sphere A there in plan. Alright, while we're at it, we might as well find the point of contact of that one. Okay, usually I do points of contact at the end, but I'll do it now. So perpendicular to the extreme generator, from the center of sphere A, and we can see the point of contact is right there. Okay, it's in this position, so it's at that height right there. Okay, and what I'm going to do then is simply project it down to my plan view. then rotate it around. And we know joining the center of the sphere in plan to the center of the cone, it has to be along this line is where the point of contact is. So once I find it here at the outside, rotate it into position, and there we go. That is my point of contact in my plan view, where sphere A touches the cone. Okay, and I'll actually call the cone C. Just put it in here, C, and POC there. And find that in my elevation. We know the height of our elevation is here, so that simply just transfers across. If you imagine it rotates around, okay, like it's on a cutting plane, a horizontal cutting plane. So the point of contact will be here. POC as well. POC. Right, so that's the first part of it done there, guys. And now what we have to do is we have to find another sphere here that was 40 millimeters above the center of sphere A. I'm going to call it sphere B, and its center is here in my elevation. The problem is we do not know what the radius is. Okay, so first of all we need to also know as well is it's going to touch this sphere, okay, and it's going to touch the cone. So the best place to get it, like we did with this one here when we brought it to the side and we had it on the extreme generator, we're going to do something similar here. We're going to draw on a sphere that is obviously touching the cone, but also touching the sphere here on the outside. And once we have it in this position here, okay, found, we can bring it down here and rotate it until it's in its correct position. Okay, so what we're going to use is locus of a line, okay, to help us find a sphere that is equidistant from the sphere A, in this case our ghost sphere when it has been rotated to the side, and the cone C. Okay, so I'm going to take out equal distances from the cone, okay, of 5 millimeters. So I'm going to do 5, 10, 15, 20, 25, okay, and I'm also going to, from the outside of my ghost sphere, okay, we're using this to help us now. Probably shouldn't have written that right there, but it'll do. So I'm going to take distances again of 5. So you can see here I did 5, 10, 15, 20, 25. So I'll do the same. 5. Now I know it's gone through my writing, so I apologize. 15, 20, 25. Okay, I can see those marks. So for each one of those, I want to basically find the path of a line or the locus of a line that is equidistant from both the cone extreme generator and the circumference of my sphere. So I'm going to set up the first one. I think the first one is going to be in here somewhere, so try and keep it neat and tidy. It's just going to be in there somewhere like that. And then I'll do 2 or 3 in the first go, and hopefully they'll work out. Next one's about 10 millimeters away, so I'm guessing it's going to be somewhere up there like that. Next one is about 15 millimeters away, so something like that, okay? So we can see all these lines here, 5 millimeters, 5 millimeters, 5 millimeters away from the extreme generator of the cone, okay? And now using my compass on my ghost sphere, I'm going to go to the first 5 millimeters I measured out from that, okay, which is there, and I'm going to mark it around and just make a little cut in there to get my point, okay? Then I'll do sorry, not number 10, but the second one out, which was 10 millimeters out extra from the circumference. So take that distance, I have it, mark it onto the second one. You can see this is working out, and then take the third distance, it's that distance there, mark it on the third one. Okay, I can see here I'm probably going to have to go another, I think another maybe 2, so I'll mark out the next 2. Marking out the next 2 using a bit of sliding set squares. So like the last one, went out to the fourth one. I'm at 20 millimeters out now, so it's up here somewhere, and I might as well do the fifth one. It's up here somewhere. Okay, and so from the center of my ghost sphere, go to the fourth one, which is 20 millimeters away from it. Mark it around. Left that one just a little bit short, so I'll do that one again. And then the fifth one, and I left that one short as well. Okay, whoops. So just to extend those to make sure that they're going through. So a bit of sliding set squares again, as I said. Parallel with the extreme generator. So that one just extended into the arc, and this one extended down. Okay, and what you'll actually see here now is we have the path of a line that is equidistant from the circumference of the sphere and the extreme generator of the cone. So I have a point here, point here, point, point, and point. Okay, so I'm going to put in that locus now as lightly as I can. Okay, hope that's coming up clear enough. Okay, so that line that I've drawn there is anywhere along that line is equal distance away from the circumference and the extreme generator of the cone. Okay, now we do know the height that our sphere B is going to be at, because it was 40 millimeters above sphere A. So from that 40 millimeters above, you can see I've it marked from here up to here is 40. I did it earlier on. Okay, I can extend out my line because I know it's at that height, and where that actually cuts through my locus is actually the center of my sphere B when it's on the outside. So technically this is once again a ghost sphere. So at that point there, right there, that is the center of sphere B, and that distance right there is the same distance from the ghost sphere here and the extreme generator of the cone. Now, just to get the radius and have it accurate, what I can do is from that center I can go perpendicular to the extreme generator. Like we did down here, we went perpendicular in there. I'll actually just change that, mark that in. So that angle in there is perpendicular. Okay, and once again, I'm simply just going to rotate that around. And at this point right here, the center to there is a perpendicular angle. Okay, but that should be from there to there is now the radius of my sphere B. Okay, so hopefully once I draw this in, depending on my accuracy, so often just give it a little test run beforehand. So I'll take that distance and see does it match up, and that's pretty close. I'm about half a millimeter out, but I'd be more than happy with that in an exam because I've proved the method. You can see in there I'm just probably a tiny touch out, okay, but I'm more than happy with that. And what we would then do is, we found that in our elevation, okay, so obviously then we have to just find, using the same radius, okay, using this exact same radius, there, take it over here, and now I can draw in my sphere B in the correct position. There we go. Okay, I'll heavy those in a minute. All I've done is basically brought it, rotated around until it's in its correct position. Okay, now we're going to do the exact same thing in our plan view. Okay, so with the center of our ghost sphere, I'm going to call this ghost sphere B. Ghost, this one was ghost sphere A. Apologies for that. Ghost sphere B. Okay, is there. You don't have to write that in an exam, but it's just helps for demonstration purposes. I'm going to bring down the center. Okay, it's in here, and it's very close to our point of contact actually. As you can see there, I'm just going to rotate it around. It's almost bang on the point of contact. So I have it here almost on the point of contact that I originally had between sphere A and cone C. So I'm going to take the radius from up here once again and just off it, it's probably off at about half a mil for me. And I'm going to draw that in here just lightly, and I'll go over these again, okay, just when I'm heaving into detail. Alright, and that is our sphere B found in our plan view. Okay, sphere B, and I'll put in sphere B up here. Okay, and the last thing then we obviously have to find is just some points of contact. So we know the point of contact is actually, we've already got it here, perpendicular, okay, so at that point there, alright, that's the point of contact when it's on the extreme generator. So to locate it in elevation, simply just project it across. Okay, very easy. I'll find the other one. So that's where sphere B touches the cone A, or the cone C I should say, and then the sphere B and sphere A are touching where the two centers join each other. And where the two centers join each other, okay, we can have a rough guess, it's right there. Okay, so at that point there, once again, you could project it across. and we can see then that it'll be in here, because all the points of contact, because they're all in line with each other here. So that's the correct one. So there, there, and there, and obviously we could see it was here, and we rotate it across. So once again, same principle applies. We're going to project it down and rotate it around. So right here, project it down, and then rotate it around. Take that distance there, and there we go. That point there, just make sure I have the right one. Yes. So that's another point of contact. That's the point of contact between sphere A and sphere B, and the last one I have to find is this guy, which was sphere B touching the cone. So I'm also going to project him down. Okay, and hopefully this is nice and accurate and it's working out for me. Just about, yeah, I'm happy with that. And there we go, that has been rotated into position. And there we go, that is technically the question completed. I'm just going to heavy in now the important details, okay? So at this point, guys, I'm going to speed up the video whilst I heavy in the important details. Okay. Okay guys, there we go. That is the question completed there. A little bit in that, just understanding guys, sometimes when you're not going to be given a radius, often they want you to use the path of a locus, okay, to find the equal distance and work out your radius from there. You can see down here guys, just understanding which one to heavy in the most, okay. So anytime a sphere overlaps a cone, okay, that's going to be in heavy, and the cone is going to be in hidden detail underneath it. And then it was understanding which sphere to heavy in, and sphere B we can see is clearly sitting on top of sphere A. Okay, so that's why sphere B here is fully in detail, and sphere A then is in detail until hidden detail inside in here, and the same with the cone. And up here, sphere A is in front of sphere B, therefore sphere B up here guys is actually has a little bit of hidden detail there. Okay, a little bit in that question there guys. Hope you understood it. Okay, best of luck with that. Alright. Hi folks, so the next question we're going to be doing guys is another solids in contact question, and it is from the Graphics and Design and Communication textbook, page 53. Okay, it's problem number 5 on page 53. So the problem says in figure 3.50, which is this guy here, okay, the plan of two spheres A and B are resting on the horizontal plane. So A is resting on the horizontal plane and B is resting on the horizontal plane. Part 1. Draw the plan and elevation of the two spheres and show the projections of the smallest sphere which rests on the horizontal plane and touches both spheres A and B. And then part 2, show the points of contact. Okay, so what it actually is asking us is we would want another sphere that is touching both sphere A and sphere B. Okay, so I'd imagine obviously if it's touching both of them, then the center of it has to be in here somewhere. We could obviously have a fairly good guess that it's in around here somewhere, but we don't know the exact position just yet. Okay, and it also doesn't tell us the radius of that sphere, so we're going to have to find the radius by finding a point that is equal distance from both sphere A and sphere B. Therefore we're going to have to use the process of Loci. Okay, and then obviously at the very end we're going to have to also show points of contact. So starting off this question guys, I've it already prepared. Okay, we can see the XY line. Keep it down close, I wouldn't say close enough, but just below halfway, and keep it to the left of your page. Okay, because in this one we're going to actually have to use an auxiliary view to help us use the Loci points. Okay, so Basically from the XY line, and then on the XY line come down at 30 degrees, and then from where that hits the XY line, 42 to there, then from here to here the diameter of A is 46, 27mm gap in between them, and the diameter of sphere B is 65. So the radius of A is 23mm and the radius of B is 32.5mm. And then obviously we can just project up the centres, mark up the radius, draw it in our elevation plan. Okay, so I'm going to get that started there now, guys. So as we can see there, I've already drawn in my plan view here, sphere A and sphere B, and I've labelled them already as well, and you can see in my plan I've heavied them in. In my elevation I've used red, okay, that's my construction lines in this case, and I haven't heavied those in, okay, because I know there's another sphere to go in here, okay. Now what we actually have to do is, at this point, we need to project an auxiliary view, okay, because that is the only way we will see, because we know a sphere has to be inside in here somewhere, okay. And the problem is that sphere is the center of that sphere, guys, is obviously touching here, and we can't actually see where the points of contact. It's not going to touch right here and right here, because we don't know the size of the sphere. It might be touching underneath and underneath, depending on the size of it yet. Okay, and then in this view, okay, that is not obviously the true projections. Well, it is the true projections of them, but we know that sphere A is further behind sphere B. Okay, so once again, we don't know where the sphere here is going to be in front of sphere A and behind sphere B and so forth. So the only way we can actually see it is when we look perpendicular to the two of them. Okay, and we can see here that the centers are obviously at a 30-degree angle and they're lined up together. So to look perpendicular, we're going to project up at 60 degrees, okay, and construct an auxiliary view. And that's the only way we can actually see the true gap between them, okay. In here, the gap is appearing shorter. We can see the gap between them is there. In our plan view, we can see it's actually bigger. And when we look in this direction of my pen, that's going to be an auxiliary view, okay, and we can see the gap between them. So what I'm going to do is I'm going to set up an x1, y1 parallel to this 30-degree angle here, okay. I'll just write that in there. 30 degrees in there, and I'm going to set up an x1, y1 parallel to that, and I'm going to keep it out of shot, so I'm going to pull it up here about somewhere. About there maybe, and center 60 degrees there. I think that should be enough. Yep, happy with that. Okay, and what I will call that is x1, y1. Okay. And now I'm going to project up my heights, okay? So I'm going to project up sphere A first. So 30 plus 60 is 90, perpendicular. Sphere A is somewhere, center is up there. And sphere B, center is up there somewhere, okay? So at this point now, projection of the plan, you take your heights from the elevation. We could take them from here because the spheres are the same anyway. So I'm just literally taking the height up, taking the radius. That height there is the radius up. Happy with that. I'm down to sphere A, up here. There's my radius. And at this point now, I'll draw it in a second actually. I'll do it in a second. So I'll take the distance to sphere B. It is there. Okay, I'm going to switch out my pen because I can actually put these in heavy. Okay. So that was the center. That's all we wanted to find, and now I can scribe in my arc for sphere A. I should say my circle. So there's an auxiliary view of sphere A, and now we're going to get an auxiliary view of sphere B. Okay, an auxiliary view of sphere A and an auxiliary view of sphere B. So there we go. Sphere A, sphere B, and I'll just bring them down a little bit so they come back into shot there a little bit, guys, sorry. Okay. And I'm actually, just to keep that neat and tidy, I always like to extend out my x1, y1 if it's out, if it's a little bit short. So that's where my x1 is, I'll write that in there again. Okay, so once again, we have sphere A and we have sphere B. Okay, and that is our auxiliary view, and I'll just write that in. So this is what would actually be known as an auxiliary elevation. Okay. Now, what we need to do is we need to find a sphere in here, in this little gap inside in here that is touching both sphere A and sphere B. So what we're going to use is the process of Loci, okay? And when we're using Loci, what I often do is I will project up a line. Actually, I have a line already, and I'm going to measure along this line here, okay? Actually, do you know what? I'm going to keep it in here in the middle. I'll project up a line in there like that, okay? You don't have to, because that line there I could have just done along here, but on that line I'm going to measure distances of 5 millimeters, okay? And I'm going to do, I think, about 4 or 5 of them again. 2, 10, 15, 20, 25. Okay, so all those distances up there, 5, 10, 15, 20, 25, okay? And I'm going to project those lines across left and right like this, okay? Make this one a little bit smaller. This one a bit smaller again, probably. Okay, and we'll see if we have to use the fifth one. Now, the reason I've done that is because that is a distance, we know it's touching, okay, the XY line, okay, or in this case the X1, Y1, it's sitting on the ground as well in between the two of the spheres, okay, sphere A and sphere B. Okay, and that distance there is 5 millimeters, 10 millimeters, and they're all equal distances away from the X1, Y1. Now we're going to do the exact same with our sphere B, okay? So I'll just take out a line here. I could have taken it up here and so on. I'm just going to measure it out, keep it out neat and tidy at the side of it. And once again, I'm going to take distances of 5 millimeters from the circumference, okay, of sphere B, 5, 10, 15, 20, 25. And if I did it for sphere B, it has to be the same for sphere A. Okay, so I'm measuring out 5, 10, 15, 20, 25. So 5, 10, 15, 20, 25. Okay, so you can see here I've done all 5s out here and 5s out here. Okay, so what I'm going to do now is I'm going to rotate my arcs to cut these measurements. So where I went 5 millimeters up, okay, that's going to correspond with where I went 5 millimeters out on sphere B and 5 millimeters out on sphere A. Okay, to find the locus of a point, okay, or the locus of a line that is equidistant from both spheres. So I've taken that distance, you can see here, to the first one out. Just come back in here and I'll mark it. So there's the first one marked. Okay, I'll mark the second one while I'm at it. Take the second distance, second one marked, third one. Now don't get confused by this perpendicular line going up here. That is just the line I did to do my measurements. My advice to you may be measure it along this one or in along this one. I was just doing that because I thought it might confuse. Okay, now I'm on to the fourth one. So it's this one here. And just about hit it. So see, I think that will work out okay. I think 4 will do it. I'm not 100% sure. We'll see in a minute. So I'm going to extend this line here. Okay, so we can see the path of a locus of a line for sphere B, okay, is this point, this point, this point, and this point. So I'm going to sketch that in now as best I can, okay. This is the locus of a line that is equidistant from the XY line, or in this case the X1, Y1, and sphere B, okay. So anywhere along that line right now, that little line I've sketched in there, if I pick the point anywhere on that, pick the point right here, that is going to be the same distance away from sphere B as it is the XY line. Okay, so we're going to do the same thing and try and get a line, and where they cross, that will give us our center of the sphere that we want. So coming back to sphere A now, I'm going to take the first one, which is that distance right there, mark it down here on the first one, then you come to the second one, then we're on to the third. Yeah, I think 4 will do. I didn't need 5. It's right in there. Make a bigger arc there so I can see that one. I'll take the fourth, even though I don't need it, but I'll take it just so you can see the path of a line. Okay, and the same thing. Okay, so this point, and you can see my third one was actually bang on it by the looks of it, but I will do it in just for demonstration purposes. So 1. In through that one, in through that one. And there we go. And it's actually pretty close to the line that I drew up the middle as well, so that was just a good guess. Okay, but what you can actually see there now, guys, is we have the path of the line of the locus from sphere B, and the path of a locus from sphere A, okay, and where the two of them cross each other gives us the center point of the sphere that we want in between the two of them, okay, and perpendicular from that center point, now that'll probably confuse you a little bit here, but perpendicular from that center point back, okay, that there will be our radius from here to here, okay, from the center down. So now I can actually draw in that sphere, and hopefully this works out. Sometimes with the locus, depending on your sketching, it can be a little bit off, but I'll test it. So from there, I'm taking that distance down to here as my radius, and what I'll do is, before I even draw it in, I'll see, does it pass close there? Yeah, it's out about half a mil there. We'll see what it's like on the other side. Half a mil, okay. So at this point then, play around a little bit. I'm going to extend it out just a touch and make it work for me. Oops, sorry. There we go. There we go, that's not too bad now. Let's see, does this side work? Okay. Now that just comes down to a little bit of poor sketching. You can see here I've touched one of them, but I have a little bit of, a little bit of a gap inside in here, and that just comes down to a little bit of accuracy on my part, okay? The method is correct, okay, using the path of the line, okay? Maybe if I wasn't using biros where the head is a little bit more blunt and I had a sharp pencil, it would be a little bit more accurate. But at that point, that is it in its correct position. Now, finding points of contact, we know simply join centers, center to center. Okay, in here you'd have a fairly rough guess. What I do in a case like this is I would simply just mark it right there like that, and obviously we have another one here. Okay, I'll say POC, POC. Okay, point of contact, point of contact. And now at this point I know the center is in along here somewhere, so where I found the center up here, simply project it back. Center is right there, and I have the radius, so I'll take that radius from above here, and it'll probably look a little bit better on this one now, because one will be overlapping, one underlapping. So it's smaller than both of them, so it's actually underlapping in both of them. Now very little under sphere A. I'm just going to put in the heavy detail first, then hidden detail, you can see here with sphere A it's only underlapping the tiniest little bit. It's quite hard to get that little bit of detail in there, as you can see, okay? And obviously with a bit of underlapping here. And now with that, project that up to my elevation. Center is up there somewhere. I have the radius, so I'll mark the radius up and then simply draw it in. And at this point here, it is going to be, looking at it here, I'm just trying to think, is it going to be in front of it or is it the side of it? As I'm looking in this direction, it is going to be, I think it's in front of it. Yeah, I think it's in front of it. So I think it's in front of it here, because A is technically further back. So that's in front of it there, but it's behind sphere B. So I'll heavy in as far as there, and then it's behind sphere B. So this will go in then as hidden detail. So there's a few tricky bits in that there, guys, now. Just on the locus, okay. A few hard bits in there. Understanding that you have to take an auxiliary view. So there's our small sphere in our elevation view, and now I can heavy in the other ones, complete the views. So sphere B in my elevation, and now I'll get in sphere A as quickly as I possibly can. Oh, nearly skipped. So hidden detail in here. And just make sure we're seeing that there. There we go. Okay, there is both views done. elevation, plan, and obviously the auxiliary view up here. And at this point now I will project back my points of contact. Okay, so it should be inside in here if I'm accurate right there, and it should be inside in here somewhere. So depending on this one, because it was a little bit funny, probably about, let's see if we'll bring that back properly. So I'm going to say it's about there. That's just my inaccuracies. So it's in there. And then we'll do the same for this guy. And hopefully this one will work out. Yeah, I think this one's working a little bit better. So it's right in there. Using obviously a pencil is probably a bit more accurate here, guys. Okay, so it's in there. And then just label them. So right there, I said that's my point of contact. And then right here, POC as well, right in there. And at this point then, it's literally a case of projecting them up to your elevation. So it's in there somewhere, and in here somewhere. Now, at this point, the only way you can actually find them is by taking the distances from your auxiliary view and working backwards. Like we took the distance from here and we went up, we can take the distance from here and come back. So it's like you take them from here, skip this view, come back to this one. 1, 2, 3, okay? So I'll take the distance up for this one. So it's up that height, we were saying. That was my point of contact height between sphere B and the small one. Okay, there. So I take that distance. I find it down here, come up here. Hopefully this will work out, and it's looking okay. So I'm happy with that one. We can see it there. Then I take the height for this guy. He's a little bit smaller. So right there, I have the height. And then what I want to do is find him down here, project him up. There he is there. Okay. And once again, just mark it. Let the examiner know. POC. POC. Okay. A little bit in that there question, guys. Obviously just my little bit of inaccuracies there, but once again the method is correct. Okay. These questions, guys, it's very important obviously to be as accurate as you possibly can, because the overall question, it is important to it then. Okay, I'd lose out on a few marks there obviously just for the little bit of inaccuracy that I had as well. Okay, hope you found that understandable, guys. The auxiliary view, taking it to understand that we had to look in here perpendicular to obviously where the centers were joining to each other, okay, between sphere A and B, because we knew a sphere was inside here, and the only way we could see the actual points of contact, which will always, they're always the most important, finding the points of contact, because that will actually tell us where centers and stuff is at. Okay, I hope you found that understandable, guys. That is the question complete there.